Good day, my name is Richard and a warm welcome to Tutoring with Richard, where we cover the South African school syllabus and nature topics. If you would like to help grow this channel, consider supporting me on PayPal, Patreon or Buy Me a Coffee. Links in the description box below. Today we're going to cover Power Machines in 6. The topic of this tutorial is steam and its formation. This is question 2.3 and 2.4. The questions are included in the video. We have been asked to issue a cautionary note. When doing these questions, please use the method I'm going to show you, as this is the method that is marked correct. Using your own method to answer questions could cost you marks even though your method and answers might be correct. See the cautionary note at the beginning of the video. On a side note, watch until the end of the video. If you watch only the first 5 minutes, you will not gain a full understanding of what you need to do. There is no quick fix in Power Machines. It takes persistence, discipline and repetition. You have to use these steps in order to succeed. Let's get straight into it. Now our question states, we are using steam tables. We are learning how to use steam tables in these questions. So the first question, 2.3, is determine the specific enthalpy of steam at 2000 kPa with a temperature of 275. So, pressure is 2000. kPa. The temperature, which I will say T soup, you'll see why now, is 275 degrees C. Take specific heat of superheated steam at, so this is Cp. Cp is equal to 2,093 kilojoules per kg. Alright, now our formula will be, now they've asked us to determine the specific enthalpy. So we're looking for H super, which is equal to Hg plus Cp times T soup minus Ts. Now let's see what we have. From the steam tables we can get Hg. From our question we've got Cp. From our question we've got superheated steam temperature. And from our steam tables we have the saturation temperature. So let's put it all together. We have Hg, which is 2797 plus 2,093 times 275 minus 212,4. So our H soup is equal to 2928,02 kilojoules per kg. All you have to do is take these numbers and stick them in your calculator, and you'll come out at this number. The next question, 2.4. Question 2.4 states, determine the specific enthalpy of wet steam at the pressure of 70 kilopascals, having a dryness fraction of 0,85. So, let's see what we need. We have our pressure at 70 kPa. We have our X, which is our dryness fraction, which is 0,85. That's all the information we are given from our question. So, what we need from our steam table, according to this formula, is HW is equal to HF plus XHFG. So, now we look at our steam table and we get 377 plus 0.85 times 2283. And then we have this number. So our enthalpy of wet steam is 2317,55 kilojoules per kg. If you found this tutorial helpful, please give it a like and subscribe. It helps to grow the channel. Positive feedback is most welcome. If you would like more videos like this, consider supporting me on PayPal, Patreon, or Buy Me a Coffee. Links in the description box below. Be at peace, be kind to each other, and remember, passing well is achievable. Have a great day. Looking forward to seeing you in the next video.